what we've depicted here is a plane mirror. And we have light coming from a pimple on the end of your nose. Okay? That light comes out in this direction and reflects from the mirror with the angle of reflection equal to the angle of incidence. Now this angle isn't very well drawn. It's a little too big. Had a bad angle when I drew it. These reflected rays appear to come from this point over here. Since the angle of incidence and angle of reflection are equal, all these angles here are the same as these angles, and this point is the same distance on the other side of the mirror as this point. So the pimple on the end of your nose appears to be here. The light appears to be coming from here. This is a virtual image of the pimple on the end of your nose. Let's look at another situation. Let's look at a fish underwater. Okay, the fish is here under the water. Don't ask me why we can see the fish and not the shark. This probably has something to do with the critical angle and total internal reflection, I guess. In any case, the rays of light come from, let's say, a fin on the back of the fish. They hit the interface and they're refracted away from the normal, so that they appear to be coming from this point. They appear to be diverging from this point, so that the fish looks a lot closer, at least the fin looks a lot closer, and the same will apply to the rest of the fish. So again, I have a virtual image of the fish right here. It's not an actual image. The rays aren't really there. We have a virtual image of the fish closer to the surface. We want to look at image formation by spherical mirror. So we have the center of a mirror. We have a ray coming in parallel to the axis of the mirror. This ray reflects through a point here in such a way that this angle and this angle are equal. Now, the normal line is the line from the center to the surface. That's just simple geometry of a sphere. So these two angles have to be equal. It turns out that by the geometry of the situation, this distance here is half of the radius. And this is the point at which all parallel rays will converge, provided the parallel rays are at a distance delta y from the center that's a lot less than the radius of this the radius of curvature of the mirror. Okay, so for small delta y much less than r, these angles are equal, and this turns out to be half of this. And to see why this is half of this, let's just look at a couple of triangles here. Now again, I've exaggerated the size of delta y. Delta y is supposed to be real small. But if we have an angle theta here, okay, again, the angle theta would be the angle of the incident ray coming in, and a delta y here. If delta y is small, this side is approximately the same as this, so that the tangent of theta is approximately delta y over r. In this figure, we have an angle 2 theta up here. If the angle is still small, the tangent 2 theta is going to be double the tangent of theta, which means that to get the same delta y, we only need half of the distance r here. So you can work out the triangles. But again, for small angles, the tangent of 2 theta is approximately the same as 2 theta, and it follows that for the same delta y, we only need half as much r if we got twice as much angle. And that's why this distance over here is half of r, because it's a side of this triangle here, from here to here to here and down. A little bit of terminology for the mirror. If S is the distance of an object from the mirror, and S prime is the distance at which the image forms. Now the image forms how? Well, we do our ray thing. We bring a ray in here, we reflect off of it. Then we bring our, the easiest ray to use is one through the focus. which then reflects back straight out, parallel to the axis. And these two rays converge at this point, which will be the head. We'll have an inverted real image here. The rays actually converge. They're really there. This is a real image. Now this real image is at distance s prime, and we have the relationship, and we can derive it from the geometry of the situation, although I don't do it here, that says if f is the focal distance, 1 over s plus 1 over s prime is 1 over f. Again, just doing a little bit of simple triangle geometry, we can verify that relationship.